number 2. Was number 2 okay? Does anyone need 2? Oh, the thing isn't on, is it? What is? What's wrong with this? Okay. Number 2, anyone? Number 4? Yeah. Number 4, yeah. A equals pi r squared dr dt is equal to 1. And dA dt, find dA dt when r equals 5. When r equals 5. Right. So with these, they need to give you one rate of change. They have to tell you one rate of change, as they do here. This one here is 1. You need an equation. So if they don't give you an equation, there has to be some information in there to get you an equation, and then you have to figure out what rate of change am I looking for. So they'll give you one rate of change, you look for a second rate of change, and there has to be an equation in there somewhere. Okay, so this is my equation. I can differentiate this and call it what? dA dr, right? Because you're differentiating A with respect to r, because the r is variable over there, right? Differentiate that, and what do you get? 2 pi r. Agreed? Right. Then set up your rate of change. You're looking for dA dt. So you want to split it into 2 fractions. So whatever's on top goes on top of the first fraction. Whatever's on the bottom goes on the bottom of the second fraction. So we have dA dt, dA dt. You look around the sum and you'll find the missing 2 spots. What will I put in? What is in the sum that's not in this equation already? dr. Right? Okay, there's a dr there, look. So dA dr, and there's also a dr there. Okay, so you haven't used the dr, so that's the missing one. So dA dt is what I'm looking for. Right, is dA dr, I've just calculated that, it's 2 pi r multiplied by dr dt is 1. Okay, so that means dA dt is equal to 2 pi r, and they told me to calculate that when r is 5. So that means everywhere I see an r, put in a 5. So that's your last job to do, right? Substitute, and you get 2 times 2 pi is 10 pi. Right? Is that okay? That's number 4. Number 6? Anyone? Yeah. Someone has to say yeah, otherwise I'll assume everything is great. Right, okay. The side of a square is increasing at the rate of 5 centimeters per second. So that's the rate of change of the side of a square. Right, sorry. Am I on? No, it's not 5, it's 6, isn't it? Right, so I have a square. The rate of change of the side is 5 centimeters per second. The unit is very handy. So it's the rate of change of the side. So what's changing? X, wouldn't it be? X is changing. So that's dx with respect to what per second? It's with respect to what? dt, isn't it? So look, it's the rate of change of the side, which is centimeters per second, so that's with reference to time, equals 5. Okay, that's the one they gave me, right? The one I'm looking for. Find the rate of increase of the area. So what am I looking for? Rate of increase of the area. Rate means always with respect to time. If they don't tell you the rate of change of what with respect to what. If they just say the rate, it's always with respect to time. So it's the rate of change of area. What's that? dA dt. So that's what I'm looking for. So that's what I'm looking for. This is what they tell me. I need an equation, right? What's the equation? I can get the area that square, can't I? What's the area that square? X squared, isn't it? X by x, x squared. There's my equation. Okay? I can differentiate that, and what will I call it when I differentiate it? dA dx. What's the answer when you differentiate that? 2x. So you're looking for dA dt. So dA dt is equal to split it up into two separate fractions. Put the dA on top. Put the dt on the bottom of the second one. Look around the sum and find the other d what? Dx, isn't there? So it's dx here and a dx here. So they have to be the same because they cancel, right? So then fill in. So dA dt equals dA dx. You have, what is dA dx? 2x multiplied by dx dt. What's that? They told me 5. So what's 2x by 5? 10x. And did they tell me x equals a number? They tell me when the side is 10, so that means x is equal to 10. So everywhere I see an x, put in a 10, so it's 10 times 10, which is 100. Is that okay? They're confusing to start with, but they'll get better, I promise. Right? I presume I'm doing 8. Yeah? Right, okay, is that good? Can I take it away? Right, 8. V equals 4/3 pi r cubed. There's my equation. dV, oh, this one's easy because they've given me everything. dV dt is 6, and it's dr dt you're looking for. So you're looking for dr dt, and r is equal to 3. That's for the end. So r is equal to 3. So there's my equation. There's my rate of change that they gave me. This is the rate of change that I'm looking for. So that's what you need, an equation, one rate of change, and what rate of change am I looking for. So you'll be given one rate of change, you're looking for another rate of change, and you need an equation. Sometimes you have to go off, get the equation yourself, sometimes they give it to you. Right? Okay, I can differentiate this, and what I call it? What I call it? I can differentiate this, but what I call it? dV dr. Why dr? Because you're over here, it's r. The variable over here is r. So you're differentiating volume with respect to radius, right? Okay. So when you differentiate that, what'll I get? The 3 comes down in front. It'll cancel that 3 there, won't it? So it'll get 4 pi r squared. Do you all see where that went? When I brought the 3 down in front, there was a fraction there, and the 3's cancelled. Okay, in case you're wondering where the 3rd went, that's where it went. Is that okay? Then we set up. So I'm looking for dr dt. Okay, so I can split it into 2 fractions. What's on top goes on top of the first one. What's on the bottom goes on the bottom of the second one. And then you look around the question to put in the missing one. So what's the missing one? Look around the question. D what is not mentioned yet? dV, isn't it? So you put a dV here and a dV here. Agreed? Right, so I need dr dV. I don't have dr dV. What do I have? I have dV dr, don't I? Right, well, how will I get dr dV? It's very similar to it, but it's upside down, isn't it? So what'll I do? Turn that upside down. So instead of it being 4 pi r squared over 1, it's 1 over 4 pi r squared. So dr dv is just dv dr turned upside down. Okay, so I'm looking for dr dt. Right, multiplied by dv dt, they told me was 6. Okay, so that means dr dt equals 2, that's 6 over 4, that's 3 over 2, isn't it? 3 over 2 pi r squared. Because look, 2 into 2 goes, 2 into 4 goes twice, 2 into 6 goes 3 times. 3 by 1 is 3, 2 pi r squared underneath. Right, and then it says r is equal to 3 centimeters. So to finish it off, everywhere I see an r, put in a 3, so it's 3 times 2 times pi times 3 2b squared into the calculator with that, and it'll be 1 all over 6 pi. Is that okay? Are we good? 10, I presume I'm doing it. Am I? Right, okay. Right, number 10. Where am I? The perimeter of a rectangle has a constant value of 40. Okay? Perimeter, we have a length. I'll just call it y for the moment. Right? X and y. So I'll go 2x plus 2y. It says they always add up to 40. Here's my equation, isn't it? Well, it mightn't be yet. Okay, right. I'll just park that a minute, see what they're asking me. Right. One side of length x, so we're changing this, is increasing at a rate of 0.5 centimeters per second. So x is changing at 0.5 meters per second. So 0.5, is it meters per second? Centimeters per second, sorry. So this is the rate of change of x, what I call it. The rate of change of x. So x is changing with respect to what? Time. Right, so what would that be? dx dt, would you agree? So that's dx dt. It's the rate of change of x. Right? Then let's figure out what they're asking me for. Find in terms of x an expression for the area of the rectangle. Okay, so part 1, let's talk about the area. Right? So the area is x multiplied by y. Would you agree? And I need it in terms of x. Right? But they also gave me this information, didn't they? So I can divide everything by 2. So that means x plus y equals 40 or 20. Doesn't it? Would you agree? And x is equal to, y is equal to 20 minus x. Because I want to get rid of the y out of the next equation. Would you agree? So if one side, the whole lot adds to 40. So if that's x, that side will be 20 minus x. Would you agree? Right, then it says get an expression for area. So area equals length by width. So the length is x and the width is 20 minus x. So I can just square that out. That's 20x minus x squared. Agreed? Right. Now, part 2 says, so this is what the area equals. So for part 2, I have my equation. I've just got it, 20x minus x squared. They've told me one rate of change. They've asked me for another one. So the rate at which the area is increasing. The rate of change of the area, basically. So what would that be? The rate of change of the area. Rate of change of the area means what's at the top? You're changing area. What's at the top? GA. And it's a rate of change, so they haven't told me with respect to what. So if they don't tell you with respect to what, it's always with respect to time. So what will I call it? DADT. That's what they're looking for. So there's my equation. There's the one they gave me. This is the one I'm looking for. Okay? I can differentiate the one I have, and what will I call it? DADX. Right? Differentiate 20x, you get 20. Differentiate that and you'll get 2x. So I have DADX. I have dx/dt. I want dA/dt. Right? Okay, so that means dA/dt, I split it up, equals, so you split it into two fractions. That goes on top. That goes on the bottom. What's around the sum that I haven't just put in yet? Dx, isn't there? So dx and dx. Got it? So dA/dx. So I'm looking for dA/dt. dA/dx. What's dA/dx? 20 minus 2x. And I want to multiply that by what? dx/dt. What's dx/dt? 0.5. Multiply into the bracket. 0.5 by 20 is 10. 0.5 by 2 is 1. So that's 10 minus x. Okay? And then it said, figure this out when x is 3. So when x is 3, just put in a 3 for x. So dA/dt is 10 minus 3. So dA/dt would be 7. Are we good? Think you're getting into them a bit? Small bit. Right, 12. Would I leave you off to see could you fix 12 and 14? Will I? Or do you think they're good? Do you want me to correct it? Tell me what you want me to do. Will I leave you fix it, or will I leave you fix it? Sarah's looking at me with her mouth open. Yeah, what are you saying, Sarah? I'll go with you. Yeah, I'll give you a chance to fix it there in a few minutes. Okay, but because we're finished this chapter, and I just have one small bit for your notes, okay? When do you differentiate? Okay, so this is just a list, right, of when you're reading a question, if you see any of these words, differentiate, okay? Is that right? So this is just for your notes before you go. When do you differentiate? Obvious, when it says find dy dx, right? Obvious, find dy dx, right? Or if they said find the f dash of x, that's obvious, right? If they say find the slope of the tangent to the curve, you differentiate. If they were to ask you, is the function increasing or decreasing, you differentiate. Because if it's increasing, dy dx is greater than naught. If it's decreasing, dy dx is less than naught. Okay? It doesn't tell you the rules, you have to learn the rules. Find if the question says find the turning or the stationary point. Turning point, stationary point, same thing. If it says find the turning point, you know to differentiate, you let it equal to 0. If they say find the maximum or the minimum, or if they give you a story about profit and they say maximize profit, or they give you, sorry, that's very bad. So if they give you a story about area and they say maximize the area or minimize the area, right, you differentiate. You look for the turning points, you differentiate. If they say find the point of inflection, you differentiate. And finally, if they say find the rate of change of something, you differentiate. Okay, so just 8 situations where you know to differentiate. So on Wednesday, you're getting a question on differentiation, okay, a test on applications of differentiation, right? Every year I give this test and people don't differentiate, right? So they look at the question and says, I can't do that, and they don't even differentiate, okay? So for the love of God, when I give you the questions, Will you just take what you see and differentiate it, even if you haven't a clue where to go after that? Yeah. Okay, girls. So for now, right, page 131, have another look at 12 and 14. See if you can make sense of them now. Right? For homework, right, we're doing the revision exercises core. Now I'm saying do 1 to 15. Okay, but if 1 to 15 is taking you 3 hours, don't do 1 to 15. Okay, so I want you to do 1 hour on your maths tonight. And if you get 1 to 15 done, that's great. If you don't, stop. Okay, it's just tomorrow is me summing up the chapter day, so if there's any outstanding questions you have to ask them tomorrow. Right, so if you try and get as much as 1 to 15 done as you possibly can, that would be great. Okay, but it's up to you. Right, if you don't finish them, that's fine too. Right, okay, is that alright? Okay, sorry, will I move it up like that?